going to talk to you today about how to build your own extension in ReSharper, how to extend ReSharper, and look at the different ways in which you can do that. But first question of all, I think, is why would you want to extend ReSharper? Why would you want to extend a plugin to what is already a plugin to Visual Studio? And I think there are several different reasons for this. First of all, you can look at the fact that actually the ReSharper team is a finite has finite resources. While they work wonders and build some fantastic stuff, there is only a limited time they have got available, and there are a limited size to the team. So there are always going to be gaps in the product which an extension can fill. We've got other reasons, such as going on a separate release cycle. So if you want to have something which is working with a third party, for example NuGet, we've got a NuGet package extension. If you want to have something which wants to update with a separate release cycle there, then you can have an extension which is distributed separately to ReSharper and can be implemented and released at a separate release rate. There are other reasons as well, such as support for third-party frameworks. If you have your own third-party framework, an MVVM framework, for example, you could write some ReSharper-specific extensions which would focus on making life better and easier for your customers. So you can create a very narrow focus for an extension and support these third-party frameworks which ReSharper isn't going to look at. Similarly, if ReSharper is supporting various frameworks, for example, if we support AngularJS and you want support for knockouts, then that can be implemented as an extension. There's also looking at corporate plugins. So if you have certain coding standards that you want to stick to, or if you have various networks that you want to talk to in a way from your coding platform, then you can write a plugin to do that. Monetization is an interesting one. That's in there. I don't think you're going to get rich quick by implementing ReSharper plugins. However, we do have a couple of paid plugins there, and it's an interesting aspect to look into. But I think the biggest reason for doing it is innovation, doing something that the dev team hasn't thought of yet, and taking ReSharper into new interesting places. It's a very extensible product, and you can do a whole bunch of different things with it. So let's have a look at quickly how can we extend ReSharper, and there are four main ways really. There's a plugin, which is the golden item here. There's the big ticket item. A plugin is a DLL which has full access to ReSharper's API and can do effectively everything that ReSharper itself can do. Then you've got live templates, which is generating code snippets or creating new files or surrounding code. Generally, it's all about generating code. Structural search and replace is a very powerful feature in ReSharper, which is perhaps underused. It's a declarative way of searching your code for a pattern of code, not just for text, but for a pattern, and allows you to replace that code in a structured manner as well. And then finally, of course, then there's external annotations, which provide hints for ReSharper's code analysis. We'll have a look at these in more detail now. So we'll start with looking at plugins. A plugin is a compiled assembly. It's usually a .NET 3.5 assembly. That means we can work from Visual Studio 2008 all the way across to Visual Studio 2013. In ReSharper, there is no real plugin API as such. We don't have a subset of the functionality which you can use and consume in your plugin to implement code. What you get is what we call the Open API. It's the same API that ReSharper itself uses. What this really means is you can get access to any public interface, class, or method. Anything that's public is fair game. You can use it, and you can extend ReSharper in just the same ways that ReSharper itself is built. This means it's very extensible. The downside to that is what I euphemistically call here, it's sensitive to product evolution. This means that as we're building the product and we need to change those APIs, then unfortunately that's going to introduce breaking changes across into your plugins. However, in maintenance releases, so 8.0, 8.01, 8.02, we maintain binary compatibility there. And we usually maintain a high level of source compatibility between minor releases, so 8.0 and 8.1 would be mostly compatible with some minor changes to source code. That then introduces the question of what versions do you support. My rule of thumb there is to support the last two last two major versions of ReSharper itself. So that'd be ReSharper 7.1 and currently ReSharper 8.0. When 8.1 comes out, I would change that to be 7.1 and 8.1 because the minor releases, the 0.1 releases, are free upgrades. And so I think it's sensible then to be able to support just the final major version of each platform there. And then there are ways of maintaining the maintaining a single code base then using the anti-corruption layer pattern there, creating abstraction over the pieces of code that have changed. Please avoid hash if defs, they're just generally considered evil. So what can you do with the plugin then? These are just some of the examples. We've got actions and menu items. You can extend the ReSharper menu, you can extend context menus. You can extend the live template system, add in new macros. You can add in items to code completion. You can create a code cleanup module to reformat your code and to make sure your code is clean and the way you want it to. Style cop, for example, is a good example here, which adds in a whole extra load of features in here to reformat the code to match the style cop coding standards. We have context actions, which are the little hammer icon and the Alt-Enter quick fix that happens when you hit a particular element within your source code. We've got analyzers, which will look at the source itself and try and find something that is incorrect or you can do better or is potential error and give you a warning, an error, a suggestion, a hint to actually do something. Those analyzers, those highlights, can then be tied up with a quick fix so that when you Alt-Enter on that highlight, it displays the drop-down list, the drop-down menu here of ways of fixing it. You can rewrite the code then to make sure it works correctly. And of course you can extend the options page, add in new pages, and you can also extend things in with the generator by implementing something which generates code, such as constructors, overriding members, equality members here. The key thing out of all of these things here is this is how ReSharper is built itself. All of these items here are things that ReSharper also implements. You wouldn't be doing anything different, you'd be doing something which just the same way. So ReSharper has hundreds of context actions, analyzers, quick fixes. It has a whole raft of live templates, live template macros, sorry, the actions and menus. So the way ReSharper itself is written is very extensible. But moving on, we can have a look at some more complex plugins. We've got language support. We've got a plugin on the gallery at the moment which is called 4T, which is a T4 language plugin. It supports the T4 templating engine, so all of your .tt template files can now have ReSharper IntelliSense and find usages, renaming and refactoring all as part of that. Unit testing can look inside your code. It can read the structure of the code, can find unit tests within there, can run them, can report them, it can display call stacks and navigate between them, and so on. Reference provider is probably one of my favorite extension points. It's very powerful. This example here is creating a reference between the string literal in the property data attribute here. It creates a reference from that string literal to a property on that class with the same name, and it can display IntelliSense to do so. If that reference is invalid, it will display as a red error, and you get the IntelliSense to tell you that that reference can't be found. That isn't a valid identifier. If the reference is found, you get control-click behavior to navigate to the definition. You also get it to participate in find usages and renames as well. So when you rename the property, the string literal itself will rename. So very powerful tool, very powerful extension point. And then of course you've got refactoring, which is all about taking your code and rewriting it to do something else. And the interesting thing about all of these ones here is that they have a deep reliance on something which is at the core of ReSharper, which is ReSharper's read-write abstract syntax trees. ReSharper continually parses your code as you're typing it, and it builds an abstract syntax tree of each file. And it's a full fidelity syntax tree. That means we keep everything from white space, and we build everything up to identifiers, to statements, to knowledge that it's a return statement. and also then a method declaration, class declaration, and a whole class file. Given the syntax tree, then you get strongly typed navigation. With a class body, you can say, give me all the method declarations, and you can then step from the method declarations to the parameter usages, and so on. You can step down into that, and you can step back upwards as well. So given a method declaration, give me all the attributes that are assigned to this to this method declaration. It's a two-way abstract syntax tree as well. You can modify it, and when you modify it, it updates the document underneath, the underlying document. So you can move elements around within the syntax tree. So you can move code up or down. You can rewrite it. You can delete a node. You can insert a new node. You can add comments, and so on. And then the most powerful thing is that it builds references to a semantic model. So it's all well and good having a syntax tree which understands that console.writeLine brackets value is a call. Breaking that down into its syntax, knowing that it's a method call on writeLine, passing in the parameter value. But you need to then also know that that is the method writeLine on the type system.console, and you also need to know what value it is. Is it a parameter? Is it a variable or a field, or is it an invalid reference? Is it something that hasn't been defined yet? Can writeLine even take value as a parameter? ReSharper builds a semantic model on top of these abstract syntax trees which you can query, and then you can build up information from there. And of course, ReSharper supports a whole heap of file formats with programming languages with C# and VB. You've got HTML, CSS, and JavaScript support, ASPX and Razor, a whole bunch of XML file formats, including XAML and web config files. And also, coming soon, we're working on C++ and, of course, TypeScript support. The interesting ones out of these lists are the ASPX and the Razor and HTML and file formats, because they can have little islands of other languages inside them. HTML can contain embedded CSS and JavaScript. Razor can contain the same, and also embedded C#. So let's have a quick look at the abstract syntax trees that we've got. Okay, so I've got a simple project here. This is just file new file new intranet website. And what we're going to do is going to have a look at the ReSharper. I've started ReSharper in internal mode, and I'll explain what this is shortly. I'll explain how to get into there. What we're going to do is we're going to have a look at the PSI. PSI is the Program Structure Index. It's our abstract syntax trees. And what we can see here is, given a C# file on the left, we can also look at, we can see what syntax tree ReSharper has built from that. So for example, at the top of the file, we've got a whole list of usings. And here ReSharper is giving us a list of usings. We can step in, we can see we've got the using token there, we've got the reference name to system, and then we've even got the identifier of the semicolon at the end. If we have a look in the namespace, we can drill into that. We can see we've got the namespace being controllers. We've got the namespace body. We've got a class inside that. We can see the attributes that are being defined on the class, the modifiers to say that it's public, and so on. We can drill in further, look at the class body. We can look at the method declaration here for login. And we can dive straight in. We've got the attributes at the top. We've got the parameter list. And we can go inside this block here, which will show us then the method body itself. For example, here now we've got the return statement, which is view. If we drill into that, we can see we've got an invocation expression. And selecting that invocation expression, we can see it's highlighted it in the text editor on the left, which is a call to the view method. Looking underneath here in the preview pane on the right, we can see that there are a couple of references being added here. This is getting back to the reference provider extension point again. This node in the syntax tree has got two references. One takes us to MVC controller view method, and another one takes us to the login.cs HTML file. You can see this in action now. If I control-click on this method here, ReSharper is now following those references to try and navigate to where it is that we want to the definition of the file. We can either go straight to the definition of the view method, or we can go to the login.cs HTML file. And if we follow that now, we can see a CS HTML file, and of course then we can have a look at the abstract syntax tree of the Razor file. At the top we've got Razor definitions here, so we've got Razor tags with HTML tokens, and and we have attribute values, and we can interrogate this, we can step into this. But what we also have, we have a C# file inside it, we have a CSS file inside it, we have a JavaScript file inside it. So the C# file is the C# is generated from a code behind file that would be generated from this. So when the CSHTML, when there is a file is compiled, it creates a C# class in the background that is then compiled into your assembly. This is an abstract syntax tree representation of that class that would be generated. And you can step in here and you can have a look at it. We can also look at the, let's just collapse that. We can have a look at the CSS section. So here we are. We can see on the left here, within the CSHTML file, we've got a style statement with a simple CSS rule set in it. And we can extend this, the CSS abstract syntax tree, and dive into this and look at it a bit closer. You can see the identifier here. The selector is a token of P, and then we've got the rule itself here, the property block, and the properties inside are created. We've got a background property with an identifier here with a value of red. And similarly, we've got a JavaScript file as well, a JavaScript segment as well. And we can step in there. This one shows us a variable definition and also an expression statement here. Okay. So let's just, actually while we're at it, we can have a look at, so for example, we've TypeScript file here. We've also got an abstract syntax tree for TypeScript here as well. This is in standard 802. This shows that we, that this is being worked on, and it's currently being worked on for the future versions. Okay, so how does this fit into the architecture of ReSharper? You can think of the way ReSharper is structured with three simple layers. At the bottom we've got the platform. This is the core .NET platform. This is shared across all of JetBrains .NET tools, .trace, .cover, .peak, and ReSharper. It provides the low-level features for everything, such as giving you the user interface and the shell for things like threading and locking and logging, and also the support for loading extensions. There's a component model, which is ReSharper's IOC container. This is the real way that extensions are added into the system. Assemblies are loaded up, and there's an attributed model, very similar to MEF, which will compose your application and bring in and register extensions. There's a project model, which abstracts away Visual Studio's project hierarchy, and this enables working with projects, files, and references and solutions. And then there's a document model and text control for manipulating files. And there's also a util section, which is has some very, very interesting features in there for not only XML reading and writing and registry and so file paths and everything, but also for lifetime management and also for data flow. There's an implementation of some code very similar to reactive extensions in there. The next level up then is the PSI, the Program Structure Interface. This is where our abstract syntax trees and our file parsers live, and also the semantic information on top of that, the type declarations. And this is what you would query then to find information to navigate around and to get the structure of your code. It also supports transactions for modification. So if you want to modify the tree, you have to start a transaction. You can make your modification and then complete or roll back the transaction, and that then will update the underlying document text. It also has support for the references between nodes. So your control-click navigation, your find usages, and your renames will work based on those references. And also supports caching. So this is the area of the code which is responsible for the information that gets stored in the _ReSharper directories. And then at the top, we've got features. These are the end user facing features. The refactoring, the navigation, the code completion, and so on. These features are built on top of the PSI. They interrogate and manipulate the PSI. They're responsible for actually changing the code and for analyzing it and finding the errors, putting the squigglies on the screen, and so on. They provide the user interface. Plugins tend to live at this level. They tend to implement live at the feature level and implement the interfaces defined at the feature level, and then consume and again manipulate and interrogate the PSI. There's nothing stopping them, but plugin from doing more than this. The T4 plugin, for example, that implements interfaces in the PSI level as well, so that has more of a vertical stripe in it. But there's generally no need to implement anything in the platform layer. And then there's Visual Studio. Visual Studio, it sits kind of below and within the platform. Platform is responsible for abstracting you away from Visual Studio and also for interfacing with it. This means then that plugins can be version agnostic. They don't have to rely on Visual Studio at all. So a plugin written for ReSharper 8 should work in Visual Studio 2008, 2010, 2012, and 2013 with no changes. You can consume Visual Studio interfaces if you need to, but then your interface, your extension becomes Visual Studio version specific, and you'll have to ship a different version per version of Visual Studio. An important point here as well is that your plugins for ReSharper cannot export interfaces to MEF, so they cannot be Visual Studio interfaces themselves, extensions themselves. This is because Visual Studio's MEF implementation requires extensions to be statically registered, and ReSharper plugins are dynamically loaded. I've got a project which I've recently started, which is aimed at making the Visual Studio integration piece there a little more interesting. So it integrates with VSIX. So there are two parts to that. There's a ReSharper extension which can install any VSIX extensions that are bundled inside a ReSharper extension. The idea of this is if you have a ReSharper extension that also wants to distribute, say, project item templates and have that appear under File New, then that can happen from a ReSharper extension. Or if you have a Visual Studio extension, the other project I've got will have a look at that will load a ReSharper extension that's bundled inside a Visual Studio extension. The idea being if you've already got a Visual Studio extension and you want to provide extra features to ReSharper users, then you can use this. That's available on GitHub. If you're interested in that, please let me know, and I can provide more details. Okay then, so how do you build a plugin? Firstly, you need the SDK. The SDK is downloadable from the website, gives you reference assemblies, MS Build targets, Visual Studio templates for projects, for items, and also for tests. It gives you a testing framework so that you can write tests around your plugin, and also it gives you some samples to follow. You can also install a checked build of ReSharper. By default, the production version of ReSharper disables reporting exceptions. The checked build will have that enabled. It also provides more details and exceptions. The exception class in .NET has a .data property, which is a dictionary to provide more information, which is very useful. ReSharper makes use of that to provide a bit more context about what's been going on when the exception happens. It also enables various asserts and consistency checks and some tracing and logging. .peek is also a very useful tool here, so you can then point that at the binaries in the SDK directory, and then you can look to see how ReSharper does it. So if you want to see get inspiration from how ReSharper implements a certain feature, you can dive in with .peek and have a look around and see how to do it. And then of course you need NuGet for packaging and distribution, which we'll have a look at in a bit. The other really useful thing you need to know when building plugins is some command line switches. The first two are fairly obvious, therefore creating and enabling the logging, and you can make use of that in your own extensions by using the logging static class. The ReSharper.plugin command line switch points to a DLL which will be loaded as a plugin, so you don't have to install a plugin before you need to be able to run it. You can just load it straight up off the command line. And then finally, the ReSharper.internal is what enables internal mode. Let's just have another look at some of the features we get from internal. The first thing it does really is enables this internal menu option here. And then perhaps the most useful thing it does as well from a user perspective when building plugins is that it enables reporting of exceptions, so they get turned on. So if you don't have the check build implemented, by default you don't see exceptions, but when you do have the internal turned on, and you click throw exceptions, there you go, you get the exception reported up here. You can click on it and you can examine it and see what else has happened. Other than that, there are lots of options then for dumping internal state information, viewing various graph information. There's also a useful end-user feature here which is used on the ReSharper team itself, which is to allow to build your solution in parallel, and also it skips projects which haven't been changed. So because ReSharper knows so much about your project and your solution, it knows when a change in a file is going to affect other files and other projects. And if it's not going to affect anything, it doesn't build it and it skips it. So this can make building larger projects much quicker and much easier. And then of course, up at the top then we have Windows useful information for looking at the PSI and for browsing everything, browsing into the type system that ReSharper knows about, for the modules such as what assemblies are being referenced by which projects, and also information such as looking at the settings store and looking at the information about the text controls. And so finally then, when we talk about plugins then, is testing. So the SDK ships with support for building tests. They're not unit tests, they're functional tests. This means that we effectively create a whole ReSharper environment with in-memory, with an in-memory solution and projects, and then we add files to that and run tests on those files. So the test we've got here, for example, is deriving off a base class provided by the SDK, and it provides a path to files on the file system, and it has a simple test called test accessor missing with a single method call in there called doNameTest. That will take the name of the test, accessor missing, and go and load up the accessor-missing.cs file. It'll add that into the project, the in-memory project that the in-memory ReSharper environment is running at the moment. It then runs the normal ReSharper analysis over the top of that, and it takes that information and compares it to the accessor-missing.goal.cs file. And as you can see, the file at the bottom here, it shows positioning and also the text of the highlights that are being used there. And if those match, then the test passes. If they don't match, then the test fails, and it gives you information about what is different. Okay, so I think we're going to take a look at annotations now. I guess, are there any questions at the moment?
Hi, Matt. Yes, we do have a few questions. The first one, are there any clean options for plugin deployment, NuGet?
Any clean options, was that, sorry?
Yes. Are there any clean options for plugin deployment?
Yeah, so plugins in ReSharper 8 are deployed as NuGet packages, and I'll actually show you some of that in a little bit then. So yes, we'll get onto that.
Okay, and there's one more question. There's a benefit to me creating a plugin for some of my end users, but they all use VS 2013 Express for web. Is it even possible for ReSharper to support VS 2013 Express? And if so, are there any plans to do so?
Sadly, no. Unfortunately, Microsoft doesn't allow any plugins other than Microsoft's own plugins to run in Visual Studio Express editions. So ReSharper just plain cannot run in there. It's a Microsoft limitation, and sadly, we can't work around that.
Okay, thank you, Matt. That's it for now.
Okay, right. So let's move on then, and let's have a look at another way to extend ReSharper, which is with annotations. You might have come across these in your own source code. They are hints to ReSharper's analysis. So in your own code, you can just add them as attributes. So for example, the top example here, we have a method getValue, which has been annotated with a not null annotation here. That's telling ReSharper that this method getValue will never return null. And so it then sees that you're comparing against null straight after the method call, and it's giving you a warning saying there's no need to do this. This expression is always true, and this will always happen. And so it allows you then to change your code to suit. And again, this is ReSharper knows this now because you've given it that extra bit of information. The second example then is a bit more interesting, and it's the implicitly captured closure message. What this is saying is that we have two lambdas here, both being passed to register handler. We've got action 1 and action 2. These are being passed in as parameters to the method, and they get captured into a closure by the C# compiler, but they get captured into the same closure. So when the C# compiler is compiling this code, it will build a inner class to this to the class in the class that we're using here, and it will add both action 1 and action 2 into that class. And when it rewrites this method here to use that, to instantiate that class to hold those values, it means that action 1 and action 2, they could have a longer lifetime than you are expecting. And so ReSharper is giving you a warning here to say, you've captured more information than you're expecting to here. Are you sure you want to do this? What you can do is, if we have a look at the example at the bottom of the screen there, is that you can add the instant handle attribute to the register handler message. And what that's saying is that the action the action is called immediately, so it's never held on to, and so its lifetime is very short. And so that will then get rid of the implicitly captured closure warning, because ReSharper now knows that the lifetime of that of those two items there is much smaller than it would be if it was just unbounded. There are plenty of other annotations available, so from can be null, not null, to string formatting. So if you give something a string format method annotation, then it will take on the whole idea that what am I trying to say? The extra help that ReSharper gives you when using a string.format method, and it will give you parameter matching that ReSharper gives you, and the extra completion that you've got there. There's the notify property change invocator, which is a useful one for extra support for notify property changed. Contract annotation is very powerful. It can say things like, if you pass in null, you'll get null here, or if you pass in null, you'll get an exception. If you pass in true, then you'll get an empty string back. You can give it a lot of information there to say, if you pass in something, you'll get something back, and ReSharper can use that to give you more interesting warnings in there. The use implicitly, the means implicit use, and the public APIs are ways of disabling ReSharper's "this method isn't used" warnings. So when ReSharper turns on the solution-wide analysis and it sees a public method that nobody is calling, it'll say this method's never used and grey it out, allowing you to delete it. You can mark it with, say, public API, and you say somebody is using this externally, and allow you to use it. There's also support for ASP MVC, so it can provide auto-completion for controllers and views and model types and so on. But it's a very powerful feature. The only problem is this requires you to write it in your code. This requires adding attributes inside your code, and you either have to add a binary reference to JetBrains Annotations DLL or paste the code directly into your own project, and from that you can get that code from the code annotations page in the options. But that doesn't help you with third-party assemblies. If there is a third party which doesn't have any of these attributes added to them, how do you make use of them? And that is where we get external annotations. This is a very nice file format. It's very, well, when I say nice, it is possibly not the most user-friendly. It's a very similar file format to the XML documentation file format. It's a way of saying, for this assembly and for this member, in this file assembly, so for example in the top here we've got system string index of, then we actually want to say, for the value parameter, then apply the not null attribute. And that then is the same as string.index of, applying the not null attribute, string value, in start index and so on, in your code. And ReSharper actually ships with a whole bunch of these out of the box. These are installed in the product file in the installation directory, and you can go and have a look. There's a whole heap of them. We have annotated all of the base class libraries, and we've provided some annotations for various third-party assemblies, such as NUnit and this example here, catalog core, which is applying the notified property changed invocator attribute to the raised property changed method here. So an external annotations file puts all of these annotations, these attributes which would be applied in your source code, into an external XML file. You can ship that they either ship in the product installed with ReSharper itself. They can ship side by side with the DLL, or you can actually ship them now as an extension in ReSharper 8, and I'll show you how to do that in a minute. So the next extension point really is live templates. This is a great way of generating code from snippets. It'll expand snippets. You can have it so it surrounds code. You can highlight something, invoke a surround snippet, and it'll wrap it such a try-catch or try-finally, for example. You can also use it to create files, and ReSharper 8's added support for generating multiple files in one go, which is very powerful. And then you can also parameterize it. So you can have parameters which are expanded by macros, so you can have them to the macro to create a new GUID. You can have it to suggest the name of a type, suggest a variable, suggest the most likely type you would have here, or just select something from a static list. And then there are special macros then for the end, for where the cursor should end, and also for where the selection would be if you're in a surround template. So let's have a quick look at this, and let's just close those. So we go to the Templates Explorer, and here are all the templates we've got immediately in there. Now we can create a new template here, but if we're looking to distribute this as part of an extension, we need to decide where to install it, and that means looking then at the settings. We've got a set of options here, but what we'll do is we'll look at them a bit more in depth under the Manage Options extension pane here. ReSharper has an extensive settings system. It's a hierarchical system as well. You read it from the top down, effectively. So the first item on the list here is your personal solution settings. As you can see here, it's named after the solution.settings.user file. This shouldn't be added to source control. So your standard git ignore file will have a star.user, and you just don't add that at all. That's kind of your top level. The next level down then is the solution settings file, which is solution.settings. You would add that into your solution file, and that into your source control, and that's shared then by the team. And whenever you load the solution file, it gets automatically loaded, and those settings are applied for your file. You've then got this computer level. This is the sort of the base level. This is your global settings, and these are then installed. We can actually have a look into the app data roaming files there, and it's the global settings storage.settings file. And then we've got extensions, and I'll come back to that one here. The interesting thing with all of this is the way various settings are applied, because if we have a look in the top left in the Templates Explorer, there's a layer here called Smart, and what that does is it allows ReSharper to decide where to put the changes that you're saving. What that means really is that it will apply it to this computer unless it has previously been applied at a higher level, in which case it'll overwrite it at a higher level. So if you have saved something into the solution settings, when you do save on the smart layer, it would save it into that personal layer there. If you don't have anything in either of those layers, it would just save it to this computer. So generally, it tries to push it down as low as it can, but it has to go one higher than where it was previously saved. I hope that makes sense. There is a whole set of blog posts on the blog under the settings category, under the settings tag, to further explain this. But that doesn't help us when we want to redistribute something. But what we can do is we can add a layer. So let's call this one templates. So I've created a new file. I've created a new .settings file in my demo folder there, and now I can change to that in here, templates, and now I can create a new template. And so now I can just start adding a template. We'll do something which will create a test method, I think. and we'll use the end parameter there to that'll be where the cursor will end up. And what we've done here is created a parameter called test method, and what we get to do is here is choose a macro. We've got a whole list, as I said before, we've got a whole heap of loads and loads of macros we can use. I'm going to use one here which ensures that a given variable is a valid C# identifier, and that replaces any invalid characters in the C# identifier with underscores. So we'll save that. We'll give it a shortcut of TM. We'll give it a description of test method, and we'll just save that. We'll close it. Let's just go and test it. Okay, so I should be able to just add something in here. If I type TM, press tab, and I can extend it. But now I can do hello world, and it's expanded the spaces for me, and it's added the underscore in. That's the macro doing that. So the macro is something which can be extended from a plugin, and this macro is actually from another extension, which is very useful. I'll come back to that. So what we've done now, though, is we have saved this template into a file which we can then use for redistribution. One thing that's very useful to do when you create a new template is to give it a category. So you get to assign a category, it's added in there, and we can do that. That means then when we go back to the smart layer, we can easily switch back to it and find out where it is, so we can easily get to it and disable it. It's a very useful way of doing things. Okay, so let's move on then, have a quick look at structural search and replace. This is, again, another very powerful way of extending ReSharper without having to write any code. It's all about declarative code patterns, and instead of having to examine the code, do textual search and replace, it can do it based on a bit of code that you actually write. So let's have a look at this one as well then. You can find this in the options menu. We can add a pattern. Actually, what we'll do here as well is let's add in another layer, and let's call that SSR, structural search and replace. And so we've got somewhere where we can save it to now. Let's add in a new pattern, and in the best traditions of television, here's one I created earlier. Let's have that. So we've got a pattern there, and what we can do, let's just get rid of that one, is we can extract all the patterns from the placeholder. So what we're saying here is we've got a for each statement. We've got a parameter T, and it's already divided. That's going to be a type. $X is going to be an identifier. Y is also going to be an identifier. I think let me just check. I think that needs to be an expression, actually. Yeah. Oh, wrong buttons. Really? Let's just get that back. Y, you need to be an expression. Okay, that's better. So we're saying S2 here is a set of statements. It can be any number of statements. S3 can be any number of statements. And then we've got DB as well, which we're going to say is an expression. But we want to actually say that this one is going to be of expression DB context. System, data entity, DB context, or derived type. So what we're saying here is look for any for each statements with any number of statements at the start, any number of statements at the end, but it's got the save changes on a DB context there. We don't want to call save changes multiple times within a for each loop. What we want to do instead, let's just grab that, is call that outside the loop. So, description, don't call save changes in a loop. We'll say format after replace, shorten any references, and let's say move save changes out of loop. And then the interesting thing we need to do here is change the pattern severity to say whether it's going to be a hint, suggestion, warning, or an error. We'll treat it as a warning. I will just add that, and then just down the bottom here we need to click Save To, and we will save it to the SSR. If we save here, it'll save it to the smart layer, which will end up saving it into this computer. But if we do save to, we can say, actually, I want it saved to my particular, this particular place. Now then, let's go and have a look at some code. We've got a call to db save changes here. This isn't in a for each loop yet, so it doesn't pick anything up there. But let's create a for each loop. We don't really care what's in it. And let's just extend the loop down, and now all of a sudden we can see that everything is highlighted. If we put if we hover over it, we see the tooltip is don't call save changes, and if we do Alt Enter, we can now move the save changes out of the loop there, and we've got the save changes method, the call outside of the loop. We've got the statements from before and the statements from after here as well. And now what we have is we have a settings file with a template, and we have a settings file with a pattern in it as well. So this then also reiterates the settings layers, but one thing it also points out is over here, the .settings files that you create at these levels, these can be shared and these can be put into a package and distributed as an extension, which I'll show you in a minute, but they can also store any settings in there. So code style, inspection severity, patterns, templates, and so on can all live in here. So there are a lot of different ways of extending ReSharper than just with the templates and structural search and replace. Okay, so that brings us on to distribution, which is probably another place to stop to see if we've got any other questions. How are we doing, Robin?
Hi, Matt. We do have some questions. So we have 4. Just let me know if you want to move on. We can answer them at the end. So the first one. If you add a not null annotation, does ReSharper flag if the code can actually return null? So does it do its own analysis to confirm the annotation?
I'm not sure I got that. So if you add the not null annotation on the return value, ReSharper knows that you will never be able to return null from that method. And if you are do any checkings for null, then they're redundant and it'll flag them as redundant.
Okay. Paul, if that didn't answer your question, please send us it again with clarification, and we'll ask Matt again at the end. So, Matt, maybe one more. How will the MS Roslyn compiler rewrite project effect ReSharper and ReSharper plugin development?
Roslyn isn't going to affect ReSharper at all. What Roslyn gives so the Roslyn project is a set of abstract syntax trees for VB and C#. It also then generates code from these syntax trees, and they will be used within Visual Studio language services as we understand it. ReSharper already has that. It already has, aside from the code generation part, it's already got the VB and C# abstract syntax trees. We're already using those abstract syntax trees for analysis and for code completion and for rewriting and refactoring. So we can already manipulate abstract syntax trees in the way that Roslyn is also promoting and looking at. So we won't be changing anything to be a part of that, really.
Okay, thank you, Matt. Maybe continue on,
Okay.
And we can take some questions at the end. Thank you.
Sure, no problem. Okay, so right, that brings us on to distribution of ReSharper extensions then. So ReSharper 8 introduced the extension manager, which is a way of packaging up extensions as NuGet packages. So instead, previously, we've had a great ReSharper has been very extensible and very, has had a very good story for extensibility, but the deployment and distribution of plugins hasn't been great. You've previously had to go to various people's home pages or GitHub pages, download zip files, make sure you unblock it, otherwise ReSharper doesn't like, well, .NET doesn't like it, and install it into a place in your app data folder. Excuse me. With ReSharper 8, we now package those up as NuGet packages. The extension manager itself takes takes charge of that. So you get a familiar interface that you are very familiar with, and you can browse. You can have a look at the ReSharper gallery, and you can see what extensions are available, and you can search. So you can search for XUnit, or we can search for templates, and it'll give us a whole bunch of useful stuff. ReSharper will also check for updates, and it'll tell us when something is available. It'll install it for us, it'll download, and it'll install it with no problems. So let's, what else is there to say there? Oh yeah, of course we get to take advantage of all of the ecosystem that's built up around a NuGet as well. So we get to use various different sources, all the products such as MyGet or Artifactory with TeamCity that can host NuGet packages for you. They get to be reused and repurposed for ReSharper extensions. We get to support things like pre-release packages as well, so they don't appear by default. As you're working on beta versions and so on, or if you're supporting pre-release versions of ReSharper, then they don't affect people who are just sticking to the released versions. You can enable and disable them. You can have dependencies on other extensions. This is a very powerful and very useful thing. So, for example, the extension the macro I used for the live template was using one of your Owen's macros here in this package, and we'll use that when we'll have to use that when we package it up. And also, yes, it's worth pointing out that this is only Visual Studio 2010 plus. So Visual Studio 2008, because it doesn't have .NET 4, can't run NuGet, and so you still need to install the extensions as previously. And then, of course, you can host packages. You can NuGet pack them, and then NuGet push, and they get pushed up to our ReSharper gallery or wherever it is that you want it to be, whether it's TeamCity, myget.org, Artifactory, file system, or whatever. And the file system is very useful if you have extensions that you only want to distribute within your company. For example, it might be a .settings file with your coding standards, or with templates that only make sense within your team, within your company, and so on. So let's have a quick look at what a package looks like. So I'm using NuGet Package Explorer here, which is a great tool if you're using NuGet. It's a way of looking inside a package and seeing what it is. This is the XUnit contrib package, which is what I maintain. It's a test unit runner for XUnit.net. And you can see that this one actually uses all of the different things we can have. We can have a plugins folder here, and it gives us then the two plugin libraries for the two DLLs which implement the plugin itself, and also the XUnit plugins themselves. The XUnit DLLs themselves. Supports XUnit external annotations. So you can see here, for example, we're applying lots of different annotations to methods within XUnit. So the XUnit assert contains method is having various annotations applied to give hints to ReSharper's analysis so it can give you better warnings, or it can disable warnings that would be false positives in this case. And then there's also a .settings file, and that includes templates for creating test methods, for creating asserts, and so on. The interesting thing with the file format is the structure here. First of all, you live under the name of the product. We're not following the standard NuGet folder structure here because it doesn't make sense for us. We're not adding references to DLLs. We are consuming plugins. So we don't have the lib folder, we don't have content, we don't have tools. We have the name of the product at the top here, ReSharper, and then underneath we have the version. This is going to be useful for future versions, because we can have a package which not only contains version 8.0 extensions, but it can also contain version 8.1, version 9, version 10, and so on. So those are, when the packages are installed, they're installed across versions of ReSharper. So when you migrate to a new version of ReSharper, your packages and your extensions will go with you, and as and when they implement support for those versions, then those will just be loaded and run for you. So right, let's have a look. I'm going to go back to my options here, and I'm going to remove the templates and the SSR. And where are we? We'll go back here. So those are my files. That's the two files I created, templates.settings and ssr.settings. And what we have is a new spec file to contain them. This is just a standard new spec file. It's got the ID, it's got a title and a version, description, the URLs for where to go to, and then tags I'll come back to dependencies, but it's also got files. So the files here, what I'm saying is load the ssr.settings file and the templates.settings file and put them inside the package as ReSharper v8.0 settings. The dependencies then, this is where things are a bit interesting. We have a dependency on something called ReSharper. This is not a real package in the NuGet, in ReSharper's package gallery. What ReSharper itself does is it says, I am ReSharper version 8.0. You need to have a dependency on me to be able to run. This means if you point ReSharper's extension manager at NuGet.org and you try and load a package from there, we won't install it because there's no point trying to install jQuery into the ReSharper extension manager. What we will do instead is we will have a look for this dependency, and if that dependency exists and is valid, then we will allow it to be installed. If it's not valid, for example, if you say, I'm actually going to be, I require ReSharper 8.1 to run, then we will put a warning up as well and we'll prevent you from installing it. We'll say it's not valid for your system. But this also means that you can say that actually I need my my extension requires ReSharper 8.0.1. So 8.0.1000 is the product version of ReSharper 8.0.1. 8.0.2000 is 8.0.2. And this allows you then to say, you know, if I require something that has that relies on a bug fix in one of the maintenance releases, you can then say that only load it for this version here. And of course, you can specify your standard NuGet version ranges. So I can say everything from 8.0 all the way up to, but not including, version 9. What we'll do here, though, is we'll just say 8.0. And as I said, the template that we had here relied on one of these macros that's already installed. It's one of these macros here. What we could do is we can have a look at the additional info. This gives us a bit of diagnostic information as to what has been loaded from the files. But it also gives us an easy way of getting at the ID here. Now we can take that ID and we can paste it in there, and we've then now got a new spec file which is relying on both ReSharper and these ReSharper macros. So now if we go to the command line, all we need to do is create a package. We've created a .new package file. If we open that up in NuGet Package Manager, we'll see you've got ReSharper v8.0, the settings files, and they're all available to use there. And if we swap back then to ReSharper, we go to the extension manager, we can click the settings button down in the left here, and that'll take us, it'll show us all the sources we've got that are available to us. We've got the my demo project here already set up, so we can now just go to the online section, we can go straight there, and then we can install it, and there it is. ReSharper has now just installed those extensions, and if we go to the options, we can see that our two settings files are available there. If we go to the Templates Explorer, we should see, yep, there it is, down at the bottom there, our test methods with our TM available to us. We should be able to use it again now. TM, hello again, and it's using the macro from the dependent plugin to actually reformat our identifier as we go through. And then, of course, to push it up to the ReSharper gallery, all we would need to do is do NuGet push and put in our API key, and it will get pushed then to the ReSharper gallery and available for everyone else to use. I won't do that because it's not a terribly useful package. And I think that then brings us to an end. That covers then everything we've got. So we've had a look at plugins, we've had a look at live templates and how to create them in a separate settings file and then package those up into a NuGet extension. The same with structural search and replace, and also we've had a look at external annotations then. And so there, I think we're finished. So any more questions?
Yes, Matt, there's two. While I'm going to read those to you, I'm going to switch over to the slideshow so people can see the links while we're talking. Okay. Can you see those? Can you see the more information links?
Yeah, that's all fine.
Okay, great. So I'll leave those up there while we're asking a couple questions. So let's see here. Are there any plans to sync the settings to the cloud similar to VS 2013?
There is nothing built into the product, however there is already a plugin which will do that. There's a plugin on the gallery called JetBox which will sync with Dropbox. There is also a similar plugin which will it will walk up the tree of file system folders you're in to try and load settings files which are not in the settings in the solution folder. So, for example, if you have a source control, if you have a number of solutions into source control, you can share a settings file across all of those solutions by putting it at the shared root of those files.
Okay, thank you. And it looks like the last question here. What happens when two ReSharper extensions provide code templates with the same name?
That's a very good question. I will have to look at that and find out. The name is a shortcut. The templates are themselves given a GUID as their actual identifier. So you'll probably see two items in the list, but then I think it will probably be a bit of a flip of a coin as to which one you actually get.
Okay, thank you, Matt. I think that's all the questions. If I receive any more by the time we wrap up here after just going through the next couple slides, we'll respond via email.
Okay, thank you very much then.
Okay, thank you, Matt. So, so everybody, here are some more information links. So you can always get more information on ReSharper Home, which is jetbrains.com/ReSharper. There's also the link here for ReSharper Plugin Development Guide and also the Plugin Gallery. You can also find more information at blog.jetbrains.com/.net and our ReSharper channel on jetbrains.tv. Another great place to get tips and register for learn about upcoming webinars is going to be on Twitter at ReSharper. And if you have any questions, again, you can reach out to Matt at CitizenMatt on Twitter or send him or myself an email. It's matt.ellis@jetbrains.com or robert.demmer@jetbrains.com. So thank you all for your time, and we wish you a great day and hope to see you at the next ReSharper webinar. Thank you very much. Goodbye.